So, hello everybody, I hope you can hear me. Welcome to this first set of parallel sessions in the Scenarios Forum, and our session is called Exploring and Expanding the Cross-Border Dimensions of the SSPs. My name is Stefan Fronzek, I work at the Finnish Environment Institute, and this session has been organized by a group of people. One of them is in the room. Henrik is waving his hand there, and Magnus is online taking notes of questions and answers, and then two other colleagues have not been able to enter this session now. So not much of an introduction actually. So we are having ahead of us a couple of presentations on the theme. So there will be first a presentation that I give myself, which is a bit of an introduction. That's why I can keep it a bit shorter here. And then we have one presentation on kind of international trade issues, another one on the finance sector, and a third presentation on security aspects, and a final presentation then on global development pathways in a national low carbon transition. And then finally, there's also one poster assigned to this session, which will be very shortly introduced at the end of the session. So, without any other introduction, could you please put up the first presentation? And I put the timer up for myself. So the theme of the whole session is kind of cross-border aspects of climate change and how that can be addressed with scenarios. And I've been working with colleagues in an EU project called Cascades, which is shown here, looking at the SSPs and trying to understand what they actually tell us about how cross-border, transboundary risks of climate change can be transmitted differently under the different SSP futures. So this talk is about characterizing the international connectivity in the SSPs for assessing future cross-border climate change impacts and responses. And I start with presenting a conceptual framework that we developed in this EU project. In this framework, we start by looking at the conventional climate change assessment or climate change impact or risk assessment, where we have an impact of climate change happening in one region, and then there are responses to this impact happening in the same region again. So that's the kind of conventional way how most of the literature, how most of the actual actions on climate change adaptation are happening, impacts in one region, responses in the same region. But then there are also impacts happening in one region that can transmit effects over borders to another region, and in which region there are other actors being affected, which may respond in different ways. So that's then shown in the second graph here, the cross-border assessment, where the impacts cross through transmissions over borders, causing actors to respond in one way or the other, and the responses may also be on different parts of these systems. An example of this would be an impact happening outside of Europe, would be a tropical cyclone in Southeast Asia that may cause a damage to a palm oil plantation, which then may disrupt supply chain, and that may cause profit falls also for companies in Europe. And then a possible response from European actors could be a substitution of these supplies, or reduced credits to firms who are active on these issues. We then started conceptualizing this by distinguishing a couple of different elements in these systems. So we start with a climate trigger, which can be either a weather shock or a slow onset event, which can be linked to climate change. So there's also the attribution to climate change, and that then causes an initial impact in one region, region A, at a certain time step, which is then having a climate-related impact in this region. And this can then penetrate through an impact transmission system through different system components of various complexity, and then reaching kind of an actor in a region B, which is then the recipient risk, and that is receiving kind of the aggregate or net impact that is transmitted to this region. And then, in addition to that, there are then responses given from actors in this region B, which can be either reactive or anticipatory, and they can also act at different elements along these impact transmission systems. So they can be targeted at the own region. In region B we are now, that's the circle here, or it can be anywhere along the impact transmission system, or the initial impact itself, or it can also be responding to actors which are outside. So it's kind of through an external system component, and that is an intervention through a third-party element. And then we, as part of this conceptual framework, we defined the context, defined within which all these impact transmissions and response transmissions are happening. And they can be for the present day, or also for the past, or for any evolving future context. So that's where the scenarios come in. And for the remainder of my presentation, I try to flesh out a bit these scenario boxes a bit better. And then as part of this framework, we also introduced a border, which you can see on the left slide. Somewhere along these transmissions, we cross a border. That's how we can create a cross-border impact of climate change. And then we've also come up with a typology of different types of these connections. And I don't want to go into details here now, but only to highlight the top row with the different categories of cross-border impacts, which we have distinguished as being either through trade, finance, people, psychological, geopolitical, biophysical, or infrastructure. And then finally, to flesh out the scenario aspects a bit better, so we may think, or we may imagine a future context in which, in a scenario where the international connections would be very strong, which is illustrated with this blue figure here, or in a different future context in another scenario where these international connections would be very weak. So what are the SSPs then actually telling us? So this is the Brian O'Neill et al. 2017 paper with the narratives of the five SSPs. We looked at these texts very carefully, and you cannot read this table, but these are all quotes from the narratives of the five SSPs that are in some way or the other relating or defining how the world is connected between different parts of the world in the future under these different SSPs. So here we identified statements which are about the political structure globally, about the global trade structure, and also some social structure mainly relating to international migration. Then we started interpreting these statements and ranking the SSPs between low and high as to how connected the world is. And we've done this from the previous table based on global policy, global trade, and international migration. And you can see here what our interpretation was. Under an SSP3 world, the international connectivity would be low under all these three themes, and under the SSP5 world, the international connections would be very high, illustrated here. We also looked at a couple of other papers. There's the global population paper, and like the global GDP paper. They are the ones which quantify, or which are the basis for the quantification in the SSP database. And they have come up with very similar interpretations of the narratives, and that was the basis then for the quantifications of the population and GDP drivers in the SSP database. Oops. Then, interestingly, finance is a sector which is actually not mentioned hardly at all in the narratives, and we will have a presentation in a couple of minutes on the whole theme. But we have done some work to interpret the global narratives in terms of what that could mean for the finance sector. So again, here is a ranking between low to high for the different SSPs. And if we then take these rankings and these different interpretations of the SSPs, you can also illustrate this in a more graphical way. So here is the typical overview figure for the SSPs, placing these five SSPs along the challenges for adaptation and mitigation. And you can plot similar figures for for the along axes that define the international connectivity, migration versus trade in the first one, migration versus finance in the second one, or finance versus trade in the third one. So that's simply a graphical way of the tables that were shown in the previous slide. And what you can see here is that whereas the challenges to adaptation and mitigation very nicely, the SSPs, the 5 SSPs cover the space very nicely by design. For the international connectivity, we are basically having more or less the distribution along the line, so we are missing some combinations here. And so one question one could ask here, is it actually possible to imagine new SSPs or an extension to the existing SSPs that pair a high connectivity with one theme or one aspect and the low connectivity in another? And I think we could think about situations where that might be actually quite plausible. Right, then we further looked at the literature, and actually we look at the first version of the SSP literature database, of which the second version was presented in the morning, and it has quite many papers, 2,300, and looking through them, trying to identify papers that would help us to define international connectivity in different ways and different themes a bit further. And actually we did not find so many papers in the whole literature database. Then we also looked at papers published after 2019, after the end of the literature database. And at the end, we came up with only 3 more papers. And no, now I need to wrap up. It's so there has been a paper on the European SSPs, regional extension to Europe of the SSPs, and that had some information, stakeholder-driven, derived information about how the EU is connected internationally and how cooperation internationally works. So that again gives a ranking between high and low for the different SSPs, except of SSP2, which wasn't considered in that paper. Another paper on the second last column here is about ranking the SSPs in terms of the risk of armed conflict. Interesting paper, which may be a result of lack of political collaboration or having other factors involved. And the last additional paper was quantifying or qualifying the risk of invasive species under the different SSPs, which would be an example of a biophysical connectivity, international connectivity. So we then thought a bit about what are the examples of issues that we may want to refine a bit further to better specify the cross-border dimensions of the SSPs. And here I list a couple of questions that we may want to address in the future. I don't have time to go through them, but just one example for trade, we may actually specify under the SSPs, like what are the free trade zones that are in place in each SSPs, if any free trade zone, what are the market restrictions or custom duties for international trade, and how diverse are supply chains. That's just one example. And also for the other categories of cross-border impacts, we come up with a couple of other example questions that we could, where we could try to develop the SSPs a bit further. Another example is questions or issues that can be refined in the future would be about the responses that are happening. They can act at different targets along the impact response transmission system. So like examples would be like the level of international disaster funds and how that develops under different SSPs, and a few other issues that are listed here. These are only examples, so I think we can probably think of many other issues that can be developed further. And then finally, the most very important point to make is that some of the regional extensions of the SSPs, which are being developed currently worldwide in many regions of the world, many of those do not necessarily make statements about how this region actually connects to other parts of the world, and that's maybe a topic where it would make sense to also regional extensions of the SSPs directly make links to other parts of the world. So in conclusion, here is the international connectivity under the SSPs. They cover a very wide range of different levels. And these levels, they are largely consistent across different dimensions, so that a high connectivity in trade, for instance, is also paired with a high connectivity in migration and finance. But one could possibly think about new scenarios where one pairs a high with a low connectivity in different themes or aspects. And then finally, that a lower level of connectivity might imply relatively lower cross-border proportion compared to direct climate change impacts that happen within the region. But this also then implies that we actually have reduced international cooperation to address these risks. So there's also, it's not only about the international connectivity that transports the risks, but it's also about collaborating and working to mitigate these risks. So with this, I come to an end for my presentation, and I think I can grant myself 1 or 2 questions if there are any on this presentation. Yes, please. And you need a microphone which is coming from behind.
Thank you. Thanks for this presentation. My question is, I go directly to the question. You mentioned this connectivity across these different dimensions, trade, migration, and others. And maybe I missed it, but I somehow have a feeling that sometimes the lack of connectivity across some dimension may be causing impacts to be more severe. So the connectivity with respect to impacts may be stronger because there is lack connectivity, for example, with respect to trade or finance or other sectors. And I haven't noticed this in the presentation. Have you considered this relationship between connectivity of the system across this different dimension and the connectivity or impacts might be the reverse or inversely proportional?
Yeah. Yes, very good point. I actually totally agree. And since we invited you to contribute to our paper, maybe you can write a section on this topic, actually. So I think it's a good point. Maybe similar to kind of that lower connectivity means also less room to work together. So it's a bit on that part also, but it's also the impact transmission itself that is affected by having fewer connectivities that may actually cause risks to others also. So I agree. Yes. Any other question?
Thank you very much. Yes, I'm Taran Fenn from Statistics Norway. I just missed one important channel, and I guess it's indirectly there, but it's about technological absorption of knowledge across borders, spillover effects of other countries' growth, and also not only growth, but also the greening technologies.
Yes, yeah, thank you. Very, very good point also. I guess we had this psychological category which may also include transmission of information, but there have also been other papers that have come up with different categories of cross-border impacts, and I know that information was in some papers being regarded as a separate category itself, which is important, of course. Yeah, I agree. Yes. Good. So I think we are up with this time for this presentation. We move to the next, which is Nina now. So we have a...
Yeah. Hello, everyone. My name is Nina Knittel. I work as an economist at the Wegener Center for Climate and Global Change at the University of Graz. Unfortunately, you cannot see the University of Graz building here. It's on this slide, but I don't know, it disappeared. I hope that's not for the other slides. I'm happy to contribute to this session with a macroeconomic assessment of global climate change impacts and how they're transmitted through international trade, and we have a special focus with this study on the Austrian economy. Before I start, just briefly, I designed this set of slides a little bit more comprehensive than what I go through now in the presentation, so if you're interested, there's additional information then online. So I don't think I have to introduce the concept of transboundary transmission of climate change impacts again. As I just learned, there are more than these several potential transmission pathways. I should update this figure, but I think it's really nice to understand the concept of this transmission. Just to point out, for our study, we focus on the trade pathway. So today's economies are strongly interlinked through global markets, and this is how climate change impacts occurring in one place can be transmitted to remotely connected places, and neglecting these channels in impact assessment disregards potentially large economic costs, which has usually been done in typical national risk assessments. So to give you an idea about the situation for Austria, this shows the most important trade flows for Austria and vulnerabilities of trading countries based on the Notre Dame Global Adaptation Index. So we see that we have the majority of trade or most important trade flows from an Austrian perspective within Europe, especially with Germany, but there is also trade relations with regions outside Europe that are potentially vulnerable to climate change impacts. And Austria is a small open economy. It is strongly interlinked in global value chains, so it's depending on imports from supplier, but also functioning export markets. And regarding the literature that addresses these transboundary impacts, we see that there is growing awareness that trade can spread climate risks, but there is still quite a lack of quantifying this climate risk. And this is particularly the case for future risk and for cross-sectoral comparison. So papers that are out there usually assess one sector or one hazard at a time. Here are some examples for this. So we try with our research to address this gap and contribute to the literature by quantitatively investigating different global climate impacts until 2050. And we also look into investigate two levels of adaptation. So the two climate change impacts that we address are sea level rise and the associated destruction of production capital, and temperature increase and associated labor productivity losses. And our research question is how Austria is affected by global climate change. So think of sea level rise, for example. We don't have a coast in Austria, so that cannot be directly affected. And which sectoral effects emerge for Austria, and how does adaptation affect these results? So I'll be very brief on the methodology and data, just a very basic info I think I need to give to you to understand the results. So we perform a macroeconomic impact assessment. Our main tool here is a computable general equilibrium model, which is a macroeconomic model that implies that all markets are in equilibrium. And then we shock this equilibrium and find a new equilibrium with climate change and can isolate these climate change effects. We have one core scenario, which is an intermediate socioeconomic and climate scenario, RCP 4.5, SSP2. I think I don't have to explain this. I will come back to that in the end. We tried further scenario combinations. I'll show you in the end the results for that. And then we account for these two levels of adaptation, very stylized levels of adaptation with low adaptation, meaning that we have no additional adaptation compared to the current situation, and a high level of adaptation where we assume explicit action to avoid adverse effects from sea level rise and from labor productivity losses. So additional investment in protection structure, and also the assumption that indoor work is not affected by increasing temperature, as we can install air conditioning, for example. Please.
Just a clarification, can you explain how the impact of climate change is modeled in the CGE?
Yes, on the next slide. I'll spare you the principles of the CGE model. You can look it up later if you're interested. And coming to the details of the climate change impact data. So for the two impact chains that we addressed here, it's important to first understand how climate impacts harms the economy, so which kind of damage occurs, then how to calculate this damage, and then how to implement it in the CGE model. So for a sea level rise, for example, this affects coastlines where population is situated, where economic production takes place, and this destroys economic productions at the coast. So in terms of modeling this impact, we destroy the capital that is used in production in the model. For labor productivity, the main mechanism is to reduce the productivity of labor in the model, which is one factor of production. So we have the two factors of production in the model affected by these two climate impacts. For more details, you can also look at this slide later. I also have here two slides that show the direct damages that will then enter the model. I will not go into detail here. This is for the two impact chains, but I will, for the sake of time, jump to the macroeconomic results. And here you also see reflected the direct damages in the specific region. So here we look at the GDP and welfare effects in 2050 for the two scenarios of adaptation, low adaptation and high adaptation. And first thing that we see is that welfare losses are much more pronounced than GDP losses. And this is the case because GDP losses also include price increases or account for price increases which are not reflected in welfare losses. Welfare losses reflect consumption possibility changes.
How did you define, maybe I missed it, how is welfare losses defined?
Welfare is a change of consumption possibilities. So with lower income or higher prices, you can actually consume less. That's reflected in the welfare. So it's about quantities and not accounting for changing prices.
Yeah, but to what extent consumption and quantity could make a consumer feel better if there is the impact of climate change?
So in the CGE
so to what extent this is, that's why I would like, if you then come back to the characteristics of the model, because this is, to look at welfare effects, do you have disaggregated type of families? Because even if you look at consumption, first of all, I'm not sure this is a good proxy if you consider climate impacts. Maybe you are happy to consume less if you think, if you know that your government spends in building security and resilience in your country, in your area. And the second, the propensity to consume is very different if you are, depending on the style or quantile of the income distribution. But in CGE models, usually you don't have.
Yeah, I totally agree. So
okay. So how can you address these issues in your model, if you thought about this? Thank you.
So in this model, we only have one representative agent. We do not account for different household types. So we cannot, this is just like for each region, there's one representative agent. We have other models where we also address this issue, but in this one, not yet. And clearly welfare is not the perfect measure for what we would imagine as welfare, but it's more than just GDP in terms of if we have higher prices, this reflects nicely on GDP, right? The GDP losses are not that large, but in fact you can consume less, so this is one option to display this. And I think it shows that there is stronger welfare losses than there are GDP losses. I agree it's not perfect, but it's better than just showing GDP. That's our intention with this. But maybe we can discuss more later. So these patterns, these global patterns, then reflect back on Austrian indicators. So we quantify this climate change impacts transmitted to Austria, especially for the trade effects. And we see, as you saw on the last slide, we have stronger impacts in the global south, stronger effects outside of Europe. And this is also reflected in the trade effects. So imports from non-European regions strongly decrease, and especially with low adaptation, where these regions outside of Europe are even more affected. This can partly be compensated by imports from within Europe, but overall imports still decrease. And the same is true for exports. So exports to especially outside Europe decrease and can partly be compensated for exports to regions within Europe, but still GDP and welfare losses are negative for Austria. We can also decompose this aggregate effect for the two impact chains and see that the main driver here is labor productivity, especially for if we assume low adaptation. This is the reason is that labor productivity is a very broad impact, so it affects all sectors. We can also look further into, the changes in Austrian foreign trade by source and destination region in 2050. And here we see again these patterns reflected, that we reduce imports from the rest of the world and increase slightly imports from Europe. So here you see on the x-axis the change in exports and the y-axis the change in imports. So the upper right panel is the increasing trade, so to say. And here, if we zoom in, we mostly see European regions, and on the lower left side, non-European regions. One exception here is Italy, which is also where we also decrease imports from Italy, as within Europe it's more strongly affected than other European regions, especially by labor productivity losses. We also looked at differential effects for the sectors, for the Austrian economic sectors. I'm not going here into detail, just to say that the two impacts reveal very different mechanisms in affecting the Austrian sectors, but you can also look at it later now. So I will want to come to this as it's especially important for this session about exploring and expanding the cross-border dimensions. As I said earlier, we tried also different scenario combinations, so SSB, RCB, and even GCM, so climate models variations. And what we find is that there is not much variation in results. So if you want to put it nicely, our results are very robust. But from another perspective, you could also say maybe these differences are not well reflected in the data that we use. So I think that the differences in pathways are either not well depicted, or maybe also they are not really depictable. So I learned in the previous presentation this nice table with the different scalings of the connectivity with high, medium, low. From a CGE modeling perspective, we would need some more concrete quantifications for that, so that we can really implement that in the model. Also, if trade patterns vary with different SSBs, so not only in terms of how strong our connectivity is, but maybe there are, like with the Ukraine war now, or we will change trade with Russia, such things are not well depicted. And the question if qualitative knowledge can be translated into quantitative parameters at all. I'll skip this, you can look at it later, and just some conclusions that for Austria, although we have quite small direct impacts within Austria, Austria is quite strongly affected by these global climate change impacts that are transferred to Austria. And while the trade effects can be quite moderate, there are stronger effects for some regions and for some sectors. And regarding the different SSBs, we think we need more useful information, quantitative information for modeling. Thank you.
Okay, thank you very much. That was a nice presentation, and we already got a bit of discussion during your presentation. Are there any more questions or comments? Henrik?
Thank you, Nina. Very, very interesting. I think this is exactly the direction we should go in this community. More detailed country-based studies. And it seems that this study also shows that high-income countries usually have rather low direct effects, but higher indirect effects, which is in line with other findings. I have one question, perhaps a comment. Your approach here is clearly about impacts of climate change crossing borders. But if I understand you correctly, while looking at effect of climate change on GDP and welfare, on the rest of the world outside Austria, you treat those countries as independent entities, not connected to each other. Is that correct?
No. So also for other countries, you could do the same analysis and then just look at the effect on other countries. So this cross-border effect really comes on like the trade relations. For if you look at it from an Austrian perspective, if you look at it from, I don't know, Chinese perspective, the GDP and welfare effects there also include what happens with trade relations. It's just that we do not look at it specifically. But the CGE model like adapts to relative price changes and relative in terms of sectoral and also regional price changes. So this is all incorporated for each country already. Yeah.
Okay, one more question. I think you were a bit quicker, and if you can maybe for the coffee break keep your question. Thank you.
Thank you very much. I'm Nicola Ranger from Oxford. So your model is sort of assuming, I guess, a chronic climate change over time in each country, and basically all countries affected at the same time. In reality, that won't be how climate change plays out. We'll see different countries being affected by different shocks at different times and then transmitting. How do you think, if we move to a model that more represented what we think will happen in this sort of more a shock mode on top of the chronic, how do you think that would change your results?
So as we have a macroeconomic model that is somehow chronic in itself, so it's a slow adjustment process, we also assume that climate change, the average climate change for 30-year period, so this is the climate change data that we use. Obviously, if we take a larger shock, the effect would be larger. And we can do that, like it's just like a matter of interpreting the data. So if you say that your model is a long-term equilibrium, it doesn't really make sense to put in a short-run shock, like a big disaster in one country and then a big disaster in another country. You can do that clearly and then you can look at it, but it's more a what-if analysis.
Sorry, sneaky follow-up. But does that, like, if we're trying to plan adaptation, does that mean that we couldn't use this type of analysis if we're planning for adaptation because it doesn't include what is actually the more realistic outcome of shocks?
We also use it for adaptation analysis, but there we also assume like average flood risk, expected annual damages, for example, in 1 year. So it's an average year, and then clearly there can be a large shock in another year. But we also prepare, like adaptation prepares for like a 100-year flood event, for example. And then if one of these events strikes, there are no damages. So we can also use it for adaptation, just to get the metrics like right. But you can also adapt the CGE model to be more represent shorter run horizons. If you reduce the adjustability, the substitution effects, and so on, then you can try to do this.
Okay, thank you very much. So now I invite Irene Monasterolo for moving into the finance issues.
Could we go to slide 1, please? I think this is the old version. It's on my profile. However, I will skim to this. Okay, don't worry. Okay, good afternoon. Thank you for being here today. I'm very glad to present a paper assessing financial risk from physical climate shocks, a framework for scenario generation that I co-authored with Nicola Ranger here from Oxford University and Olivier Mahoul from the World Bank. This is one of the outcomes of a World Bank project that in which we were involved together for the last 2 years, where we assessed the macroeconomic and financial impacts of climate risk. We consider the acute risk and their compounding with the COVID crisis with a stock flow consistent agent-based model. introduction. So what are our paper address? So it addresses one of the major gaps in the representation of climate physical risk in scenarios that are then used by investors, central banks, and financial regulators for climate stress tests. And this major gap is about the representation of acute physical risk, which are, for instance, floods, hurricanes, droughts, which are nevertheless able to generate significant economic and financial losses already in the near term, which is what now we are missing. And what's worrying now, financial regulators that cannot show that climate change could lead to recessions. Acute shocks can affect firms and financial institutions even far away, which is the concept of cross-border risk. Indeed, how? Well, imagine, for instance, European financial institutions that hold financial contracts and, for instance, equity holdings or bonds of firms which have plants located in areas in third countries which are affected by floods or hurricanes. The plant gets destroyed, and thus the shock would cascade on firms' revenues. And from firms' revenues, you will have an adjustment in the value of the financial contracts associated, issued by the firm, and from there to a negative shock on the value of the portfolio of the investor who owns such contract. Finally, what we introduce in this analysis is the concept of compounding. Indeed, we know that climate change doesn't happen in isolation, but as the COVID crisis showed us, several low-income and emerging countries were hit at the same time by acute climate physical risk, like in particular hurricanes, which is the focus of our analysis, and COVID and pandemic crisis. When these shocks compound, we have an amplification both in the magnitude and in the duration of the losses in the economy. If we neglect these characteristics in the scenarios, we somehow underestimate the potential economic and financial losses, and this matters for both for investors who want to optimize or rebalance their portfolios in the face of climate risk, but also for financial supervisors who should check that investors have enough capital to withstand such potential shocks. Thus, in this analysis, we identify some knowledge gaps. We discuss acute and compound risk transmission channels to the economy and finance, and we show an application that we did on 2 East Asian countries using the Erin flow consistent model. So, here we have an example of the transmission risk channels when we consider direct, indirect, and potential contagion impacts of natural disasters. As I said, in this analysis, we focused on hurricanes. On the left, the blue boxes are the impacts in the real economy, and on the right, the yellow boxes are the impacts within the financial sector. So let's take, for instance, an example of natural disasters which impact productivity of firms, including business disruption. Well, we will have transmission in the economy via reduced income and revenues, and increased loan delinquencies and foreclosures, so potential inability of the firm to repay loans. This is what happens in the economy, but then we will have also, since in our model, we have firms, we have economic and financial actors, so firms borrow from banks in the simplest case, then banks will suffer depletion of capital levels, so capital adequacy, as well as potential withdrawal of bank deposits, so liquidity problems. And all of this would lead to reduced profits levels and earnings for the bank. Then we consider also the fact that banks don't exist in isolation in the financial system, but they are interconnected. And this was one of the issues of the last financial crisis that led to amplified shocks. And indeed, a shock on bank's balance sheet could cascade and lead to contagion if depending on the structure of the financial network and depending on the leverage and interconnectedness. Finally, we would have, from our initial natural disaster, we could have also contagion into other countries via reduced trade and investment. Another example would be the impact of disasters on damages to capital, including physical assets, which would, however, this is quite interesting to see, have different transmission channels in the economy and to the bank. If we consider the shock on damages to capital stock, we would have an impact, a negative impact on the asset value, which would lead to a reduced value of the collateral, so asset quality, which will affect, again, the capital levels, so the capital adequacy of the bank. On the other hand, we would have an impact on the demand for recovery and reconstruction. And the bottom, oh, sorry, no, can we go? Okay, which would affect the demand for financing and thus lending from local bank and from foreign. In particular, in low-income and emerging countries, we would have also support from non-local and foreign banks. For the sake of time, we go to the representation of climate physical risk in current NGFS scenarios. So here is where the problem stands, because the NGFS has done massive work in trying to develop climate scenarios to be used by investors and financial supervisors for climate stress tests. These scenarios mostly focused on transition risk. When it comes to physical risk, they mostly focus on chronic change, so long-term change in temperatures via the EasyBeam models, and consider as acute changes frequency and severity of tropical cyclones so far. And they then translate these shocks on direct losses in the economy, but overall, the full macroeconomic impacts are not captured yet, and neither the models used, the macro models used, make a connection with the financial impacts. Thus, based on this evidence, we identified 5 areas that are critical to strengthen the scenarios to improve the relevance of the results of climate stress tests when we consider physical risk. The first is the need to represent current and future term risk from climate extremes, including their impacts on infrastructure systems, supply chain, and productivity. The second is to fully account for uncertainties in climate and impact models, ensuring that scenarios explore the space of potential future outcomes and consider then the uncertainty. The third is to include compound shock scenarios and their relation to the economy and finance. The fourth is to represent the indirect and cross-boundary impacts of acute shocks, including regional and global cascading impacts that we are studying within the Cascades project. And the last one is represent the feedback between the financial sector and the economy, because when we account for this, we can see an amplification of the direct impacts of weather. So when you account or don't account for finance, and in particular for investors' expectations about risk of scenarios and the potential adjustment in investment decision, then you will have different firms' investment in the real economy and thus the realization of scenarios. Briefly, we illustrated our framework on 2 countries from East Asia, from Southeast Asia. We developed scenarios characterized by individual acute physical risk and compounding impact of COVID and hurricanes. We identified the risk transmission channels across sectors and the drivers of reinforcing feedbacks in the economy and finance. We assessed the indirect and cascading impacts on agents and sector of the economy and on financial risk metrics, such as capital adequacy ratio, accounting also for the fiscal and monetary policy response that was put in place by the country analyzed during the COVID time. And finally, we quantify the non-linear impact of compounding on GDP, introducing a compound risk indicator. Yeah, This is how our scenario framework look like. So we have one scenario, the first one characterized only by strong hazards, the second one which is characterized only by COVID, the third one which is characterized by compounding COVID and mild hazard, so mild typhoon, and the fourth one characterized by compounding COVID and strong hazard. The analysis is done using a stock flow consistent behavioral model, which is the ERI model, which has heterogeneous agents and sectors of the economy and finance. And for instance, it includes banks, it includes central banks and financial markets for stocks and bonds. The peculiarity of this model is that actually don't need to constrain agents to be representative. Indeed, we have a limited number of, however, heterogeneous agents. And agents are not fully optimizing and forward-looking because in the context of climate change and the deep uncertainty, we cannot assume that markets clear prices and that investors have all the information they need to be forward-looking. So we have adaptive expectations. Briefly on the results, here we see actually we take the impacts of the compound scenarios on GDP, and here we can see actually we build a compound risk indicator that shows the non-linear effect of the compounding on GDP of each country by quarter through time. Of course, if the compound risk indicator is greater than 100, we have non-linearity. If it's smaller, or it can be otherwise smaller or equal to 100. And if it's equal to 100, actually the impact of the compound is equal to the sum of the two individual shocks. What we see here, however, is that for both country A, blue line, country B, yellow line, actually the impact of compounding is positive, meaning that, and increasing through time, meaning that we have a persistency of the shock and sometimes an amplification of the shock on GDP through time, so non-linear effects. So to conclude, okay, this stopped. Okay, to conclude, what we can get from our analysis is that uncertainties are not new or unique to climate financial risk assessment and stress testing, but we can already learn a lot from what has been done in different fields: climate economics, climate science, and financial risk analysis. Scenarios for climate stress tests, in order to be relevant, they don't need to be complex, but should represent all the material financial risk drivers, their key transmission channels, and plausible future outcomes. Right now, we are not there. With our analysis, we provide a new scenario framework that allows to include acute physical risk and compounding of shocks and with that, we can already see larger economic and financial shocks that are missing in the literature. And this, we believe, would better support climate-aligned investments and investment decision and also financial policy making. Thank you.
Thank you very much. Great presentation. Any questions? Piotr was very quick.
I know it's not enough time, but I'd be very curious if you could say a little bit about the representation, internal representation of the agent-based model that you have used. I mean, now people here at IIASA, Sebastian Polena, Stefan Turner has developed this agent-based model with every household and every firm. And I'm not saying this to challenge you in any way, because I'm not sure it's the best representation, but I'd be curious about the level of disaggregation that you went to with your model.
No, that's a great question, because also in the agent-based modeling community, we have been debating for the last at least 10 years since I joined that about how many agents we need. Probably, and I know that model very well because I worked with the other part of his team in another in a Klimafond project. Maybe we don't need 8,000 households to represent the potential responses of households to shocks, depending on their income, their skills, their education. So the idea behind the model and how we implemented it, and it was quite important discussion in what we put in, we keep in or not, was to try to keep the complexity at a level which was manageable, also in terms of equations, to try to understand what's happening and try to provide a statistical validation of the results, which is what we did as well, because we had to present the results to central banks and clients, so the World Bank, so they had to be also with, let's say, they had to trust and to understand why we got what the results that we got. So this is what we try to understand. However, we have, for instance, households which are heterogeneous in terms of income source and level, but also access to financial market. We have sectors which are characterized by, which are either labor or capital intensive, low carbon or high carbon. We have an energy sector which is characterized, which has mining companies, utility brown, utility green. So there is this level, there is some level of heterogeneity.
Any other question? Henrika, you're checking online if there are any questions, but yeah, I haven't said that earlier. Those who are connecting online, you can put your questions in the comment field on IIASA Connect for this session, so you may still do that. Please.
So one of the things that I've really enjoyed about working with you, Irena, is understanding how different models, macroeconomic models, drive quite vastly different results in the outcomes, and I think your model particularly captures a number of elements well. Why isn't there a model intercomparison project for macroeconomic models? Because it seems like we really need one.
Yeah, that's, I mean, that's absolutely, I mean, we deserve a kind of 10 million Horizon project, but I think it will be much needed. I think, I mean, having worked in my life with different type of models, because during my PhD, I did a CGE model as well. Then I moved to system dynamics and then networks and then this type of models. I think that the reason is because why we don't have this type of project is that as a difference from the integrated assessment modeling community, which kept on comparing their models and running their models on the same scenarios, in economics, actually, every model kind of represents a view of the world, and thus communication was very limited so far.
All right. Yeah, so my presentation is about implications of different SSPs for the Finnish low-carbon transition. Let's see, how does this work? Doesn't seem to work at all. Oh, I hold it, okay, good. So, as Stefan already said, I'm Fanny Grundström from University of Helsinki. I'm a doctoral researcher, and this presentation is about the research that I'm currently doing for my third PhD paper, which is still ongoing. So, some background. Finland has set a target of becoming carbon neutral by 2035 and carbon negative as soon as possible thereafter, which is a very ambitious target. And this will be achieved by different measures in different sectors, but in this study I mainly focus on the decarbonization of the energy sector. So it's often assumed that a low-carbon transition will result in fewer interconnections to other countries because of more domestic energy production. But a low-carbon society is in fact likely to include many international interdependencies due to, for example, regional electricity grids or dependence on imported rare earth minerals. And also factors such as cost competitiveness between different regions or social resistance towards large energy infrastructure or land use change could in fact incentivize international energy trade in the future. And also local energy markets are affected by energy prices in the rest of the world, as well as by international energy and climate policies. And in an interdependent low-carbon society, it seems logical that also cross-border impacts could be of importance. But neither cross-border impacts nor global contexts are sufficiently addressed in low-carbon strategies or scenarios, which makes them ill-suited for adapting to unforeseen or unexpected developments. So in my research, I'm assuming that the Finnish low-carbon transition will be affected to some degree by how the rest of the world evolves. And I'm interested in finding out if or how cross-border impacts could emerge and materialize differently in a Finnish low-carbon society, depending on different socioeconomic developments, how the rest of the world evolves. I started with, or we started with, examining Finnish low-carbon transition scenarios in order to identify key assumptions regarding how the decarbonization should take place and what is needed for reaching carbon neutrality. And we then linked these Finnish scenarios to the global SSBs in a general morphological analysis in order to place the Finnish transition in a global context and identify challenges and opportunities for the Finnish transition stemming from these different socioeconomic developments globally. And we're currently conducting interviews with experts where we ask them to reflect on potential implications of cross-border impacts for the Finnish transition based on different SSBs. And the idea is to then assess some of these impacts more thoroughly through this transmission and response framework that Stefan already mentioned. So there's two national scenarios that have been developed in Finland that lay out potential pathways for achieving carbon neutrality by 2035, continuous growth and conserve. And both of these scenarios assume a rapid and substantial ramping up of renewable energy production and electrification, and a phase out of unabated fossil fuels and increased energy efficiency, decreased energy demand. And this should be enabled by cost reductions of low carbon options, wind, solar, but also nuclear to a large extent, commercialization of nascent technologies, and smooth technology transfer in a cooperative world. And they also assume that international policies will create a supportive setting for investments and international trade and diffusion of know-how. And the main difference between these scenarios are the use of carbon capture and storage, which is widespread in conserve but absent from continuous growth. And then they have some variations in attitudes and behavior and preferences. And these variations, these differences lead to subtle variations in energy system characteristics between these two scenarios. But that's not important right now. So we then linked these Finnish scenarios with the SSBs in a general morphological analysis. So we first identified common elements or parameters that were found in both the SSBs and the Finnish scenarios, and then a set of states or values for each parameter. And this is just a small part of a much bigger GMA. And in this study, the SSBs were used as boundary conditions, resulting in a morphological field consisting only of the range of values provided by the SSBs. And then we chose for each parameter, we chose the state, or we identified the state that best aligns with the Finnish scenarios, sort of to kind of see how the Finnish scenarios compare to different SSBs. And of course, the main assumption or the main insight from this general morphological analysis is that the Finnish scenarios were best aligned with the states of SSB1 in most of the cases because of the common aim of moving towards sustainability. But in many cases, the Finnish scenarios were in fact better aligned with SSB4 or 5, but the SSBs of 2 and 3 didn't really correspond with any of the Finnish assumptions. And because the basic SSBs don't include any climate policies, but the Finnish scenarios hinge upon successful global climate negotiations that will lead to the below 2 degree target being met. So we also did a GMA with mitigation scenarios in which the SSBs are compared with RCPs and SPAs, and we used the least stringent mitigation scenarios that have a high probability of meeting the 2 degrees target, so that's the ones compared with RCP 2.6. This level can be reached in at least some of the modeling simulations for all of the SSBs except for SSB3, so for that scenario, for that pathway, we used SSB 3.4, which is the most stringent available, but it still leads to the below 2 or the 2 degree target being met. And here is just a small snapshot of that mitigation GMA. We still see here, even though this is the mitigation scenarios depict worlds where a global low-carbon transition is taking place. So it better aligns with the Finnish scenarios, brings them closer to the Finnish scenarios. But we still see here the same kind of SSB 1, 4, and 5 alignments, but a poor alignment with SSB 2 or 3. Some major differences are that the mitigation scenarios still assume higher unabated use of fossil fuels, for example. And the Finnish scenarios they all use nuclear power and bioenergy to a large extent. They are not always present in these mitigation scenarios. So here is just a summary table of some of the key assumptions that we found in the Finnish scenarios that could be affected by global developments. And these are all related to the international market for energy technology or international cooperation or global climate policy ambition. So the red ones are incompatible, the yellow ones could be compatible, but they're challenging, and then the green ones are compatible. So here we still see 2 and 3 doesn't compare well. 1, 4, and 5 could potentially facilitate the Finnish transition. So now that we've established that the Finnish transition could be affected differently depending on how the world evolves, we use this same cross-border impact pathway and the same pathways, 7 pathways that Stefan already mentioned. We use them in the interviews where different kind of impact pathway, SSB mitigation scenario combinations are considered. And the idea is that then even if climate change would be kept at more or less the same level as in the mitigation scenarios, cross-border impacts could still differ due to different SSBs. And we've done a few interviews already, but we have still more to come. So I just have some preliminary results. But some ideas that came up during these interviews, for example, in an SSB1 world where nuclear is not, it's phased out everywhere else, then that would make it nuclear difficult to, it would be more expensive in Finland, for example. In an SSB2 world, renewable energy technology prices remain high, and international climate action is quite slow, so that could hamper the Finnish transition. SSB3 could spur a more regional conflict due to climate change. As we all know, that could have major implications for global energy markets. SSB4, disruptions to renewable energy technology trade, supply chains due to climate change is a real risk in a world where adaptive capacity is lacking in many places. And SSB5, it's the world which hosts the largest network of international electricity grids. So that makes the risk of physical impacts to electricity supply more prominent. But these are just some preliminary results. And the idea is to then use this transmission response framework that Stefan talked about to more thoroughly assess some of the impacts and more concretely and better illustrate how international interconnections could lead to cross-border impacts on the Finnish energy transition or a low-carbon energy system. So in conclusion, there are several options for achieving a low-carbon transition. As we see with the alignment of the Finnish scenarios with both SSB1 and 4 and 5. But our Finnish transition will be affected by how the rest of the world evolves. And a major restructuring of the world is needed in a low-carbon transition, so that's why we see an incompatibility with SSB2, and global cooperation is essential, so we see an incompatibility with SSB3. And it's likely that the Finnish low-carbon transition will face a different suite of cross-border impacts depending on which development pathway the world will take. So even if climate change is kept at more or less the same level, so physical impacts would be more or less the same, transition risks and impacts to the global energy market could still differ depending on how the world evolves. And these impacts should be identified so that appropriate adaptation measures can be put in place. Okay, that was all I have. Thanks.
Thank you very much. Great presentation. Any comments, questions? Henrik.
Thank you, Fanny. Very, very interesting. I can easily see the policy relevance of this work. So I was curious about, has this work been initiated or by policy needs, or are there any links to policy right now, or is that something that comes later?
No, it's just me and my research group, mostly me, with some help from my research group. But there are ongoing political initiatives in Finland that wants to identify adaptation challenges and include them when we go forward. There's a lot of, since Finland wants to become carbon neutral by 2035, there's a lot of heat around this topic right now, and a lot of things going on.
There was a question.
Thank you. Excuse me. I had a similar question actually, because you can really sort of see the policy relevance of this, and I just wondered, how does a policymaker use this information to inform planning? I can imagine that you could link this with some sort of real options analysis or robust decision making, where you could look at sort of critical decision points for the Finnish government, where it decided what changes in decisions would need to be made to manage transition risks. Because that's one thing that strikes me under these different scenarios. The transition risk to Finland is vastly different. So I wondered if you'd thought about, maybe that's a fourth paper in your thesis, like how you would link this into some kind of decision tree, decision-making framework, and that a policymaker could use.
Yeah, I've thought about that, because while I was considering different options, different methods, I came across these decision trees as well, and the thought, I thought about it that this would be really useful, but then that would be more of a policy. I would have to include or get some policy people then with me, but it would be really interesting, and as you said, it could be a fourth or fifth paper. No.
Okay, one final question on this.
Yes, thank you. I have one technical and one policy question. The policy question is the commitments of reaching net zero. Is it a commitment or is it an ambition in Finland?
It's a commitment.
Okay.
Yeah.
But then they can buy quotas or offsets as a rescue if this becomes too heavy.
Yes. Yeah. It's quite new. This whole idea or this whole ambition, this goal of carbon neutrality. So not much actually has been done, except these few scenarios that set out possible pathways for achieving it. But yeah, there are a lot of hurdles on the way. So a lot of options would need to be taken into account. If this doesn't work, then what should we do then?
And I also wondered, will you do some quantitative analysis of this? You said you had some parameters that you'd already quantified. Will this be a model study in the end?
No. I'm just kind of, the parameters were used just kind of to highlight the interconnectivity. But it's more of a qualitative study at this point, at least.
Thank you.
Okay, thank you very much, Fanny.
Thank you.
And I hand over the microphone to you. So as the final speaker, without any presentation, can you say your name? It's so difficult, I cannot pronounce it.
Hosseini Khalilu.
Yep. So Hosseini is having a poster on the poster session later, which is assigned to this session, and he will shortly present the theme of his poster.
Thank you so much, Stefan, for the invitation to talk about my poster presentation, and I would be very grateful if you all could come to my poster, giving me insights, guidance, public collaboration. My name is Hosseini Khalilu. I contribute to the UN Security Climate Security Report number 5. I'm originally from Niger, Central Sahel, precisely tri-border area of Mali, Niger, Burkina Faso, one of the hardest spots of climate security, environmental peace building. I'm based in the United States, where I'm a member of Environmental Peace Building Association. I'm also an ecological security fellow at the Converging Security Lab, an institution of the Council of Strategic Risk, a think tank based in Washington, D.C. My poster, please don't be surprised if the title looks different from this one that was shown earlier. That will be a very important part, the food insecurity, but I'm trying to focus on Sahel region, talking about the cross-border dimension of the SSPs. Something I'm working on, which actually as an extension of a book chapter. I'm contributor in a book which will come out in July, but I would be really grateful if you could give me insight and guidance on that. I guess I got my 2 minutes, all right? I could go on. Okay. Cross-border dimension of the SSPs focus on the Sahel region, the immigration, focus on the immigration between the three countries. I'm using a pattern matching in case studies, combining with the SSPs. So.
Okay, thank you. And I think there's probably beer and wine with the poster session, so we all come and have a drink at least. So
yeah, and I would really like to see all you and giving me advice, please.
Okay,
thank you.
Thank you very much. So with this, I thank all of the speakers, great presentations, and a big thank you also for a very active and really good discussion. And I know that there have been some pressing questions where there was no time to ask them. So let's take the time in the limited coffee break we have left now before the next session starts. So thanks a lot.